Hello there and welcome to our new lesson. This video is for senior high school general mathematics for grade 11. Prepare the following: a paper and a pen for you to write your answers or solutions for the problems later on. And remember, you can always pause and play this video whenever necessary. You can even go back or revisit the portion of this video to clarify some things for mastering purposes. I hope that you are all excited for this, so let's hop in. This video presentation is for the first quarter, Module 1 of our subject General Mathematics for grade 11. The topic is real-life functions. To be specific, this is for the first lesson about real-life functions. What you need to know. We have three main objectives for this session. The first one is you're going to determine functions and relations. Second, illustrate functions through mapping diagrams, sets, and graphs. And finally, you're going to represent real-life situations using functions. What's in? What you see on the screen right now is a crossword puzzle. Exactly! We have here 5 descriptions of different terms that is related to your junior high school mathematics. These are necessary terms for us to proceed with our new lesson. Okay? So, you can pause this video and try to recall those important terms. I'll give you time. Go ahead, pause the video. Are you done? That sounds great. So let's reveal the answers. So for number 1, let's have number 1 down. A rule that relates values from a set of values, which we call as domain, to a second set of values, which we call as range. What do you think? The answer is relation. So let's put it in our crossword puzzle. Relation. There. Number 3, 3 down. Blank pair. Pair of objects taken in a specific order. What do you call this? Blank pair. The answer is, it's an ordered pair. Very good. So let's put it in our crossword puzzle. Now to clarify about ordered pairs, we have here an example. Remember that ordered pairs are a sequence of 2 elements. Like for this example, 1 and 2, they are enclosed in a parenthesis and they are separated by a comma. Okay, that's an ordered pair. Let's proceed to the next one. How about across? Number 2, the set of all x or input values. Can you recall? You have here your clues. O and I for the second and the second to the last letter. And the answer is domain. Right, brilliant. Domain. Let's review about domain. When we say domain, look at the example. We have 4 sets, or we have 4 ordered pairs in this set. 1, 7, 2, 6, 3, 5, and 4, 4. Now, what is our domain here? Our domain are the first elements inside the parenthesis, or first element in each of the ordered pairs. So that means it's 1, 2, 3, and 4, which serves as our domain. How about for number 4, across? Collection of well-defined and distinct objects called elements that share a common characteristic. You have this when you're still in grade 7. The answer is, well done, that's set. S-E-T for set. Last one, across number 5. The set of all y or output values. What do you call that? Your clue there is it ends with letter E. You already have the domain. This is the pair of domain. That means we are referring to the range. Okay, we have completed our crossword puzzle, but before that, let's clarify on range. Now, using the same example for the domain, we have here this set of ordered pairs. We already have 1, 2, 3, 4 as our domain earlier, right? Now, this time, the range is these values. The second element of each ordered pair, or the y values. That will be 7, 6, 5, and 4 in this example. What's new? What makes relation a function? A function is a special kind of relation because it follows an extra rule. Just like a relation, a function is also a set of ordered pairs. However, take note of this. Every x value must be associated to only one y value. I repeat, every x value must be associated to only one y value. That's the most important part of this lesson. Remember that. That's for the definition of our function. Illustrations will help us a lot to learn functions easily. So we have here mapping, sets, and graphing. A function is a special type of relation, always remember that, in which each element of the domain is paired with exactly one element in the range. A mapping shows how the elements are paired. It's like a flowchart for a function, showing the input and the output of values, like this. The domain for the first set, and the range for the second set. Now in this mapping, let's identify if this is a function or not a function. How do we do that? Recall, every x value must be associated to only one y value. So based on that, let's try to check if every element in our domain is associated to only one value in our range. Let's focus on this part. Our domain A is associated to Roman numeral 1. So that's 1:1. That's the correspondence. Second domain or second element B, that is associated to only one Y value. That is Roman numeral 2. Here, C, third element of our domain, is associated to or is being paired to only one value of Y. That is 3 or Roman numeral 3. And lastly, D in our domain is being paired with Roman numeral 4 in our range. So as you can see, every element in our domain is being paired to only one value of Y in our range. So that means this example is correct. This is a function. Let's look at example number 2. Can you identify if the given is a function or not a function? You may pause this video. Okay, alright. So how about this example? This is still a function. Why? Looking at all the elements of our domain, -3 is being paired to 0, -1 is being paired to 4, 2 is being paired to 7, and 4 is being paired to 4. So this shows that every element in our domain is being mapped or is being paired to only one value in our range. Which means that if we have an input of -3, the output is only 0. If we have an input of -1, the output is only 4. We don't have any other Y values. If we have an input of 2, therefore our output is 7. If our input is 4, our output is also 4. This type of correspondence shows many is 1. For this part, we have two elements in our domain. Here, that's -1 and 4. We have two elements in our domain that has the same value in our range. Take note, what we are referring to in a function is we have every element in our domain is paired with one element in our range, which means that for every input, there's only one output. This type of correspondence is considered as a function. I hope that's clear. So this is a function. Third example, how about this? Is this a function or not a function? You may pause this video. And let's reveal, this is not a function. Why? Earlier, we saw many is the one correspondence, right? This time, you call this type of correspondence, recall your grade 7 and grade 8 mathematics in your junior high school. This is, for this element in our domain, which is letter A, it's being paired, let's focus on that. Here, that's our domain, A. It's being paired to 1, Roman numeral 1 in the range. At the same time, the same element in the domain is being paired to Roman numeral 3. Now that means this element in the domain has two outputs, 1 and 3. Which is clearly a violation of the definition of our function, right? Therefore, basing on that element, this example is not a function. I hope I made that clear. A is being paired to two values in our range. We're done with the mapping. Again, these are illustrations to help us out understand or identify if the given is a function. So this time, let's move on to sets. Sets, in this example, we will have rooster notation. So we have a set of 4 ordered pairs, beginning with 2, 3, 4, 5, 5, 6, and we have 6, 7. Now, can you identify if this given set is a function or not a function? Now, how do we do that? Let's identify first the X and the Y elements in each ordered pair. So for the first one here, 2 is our X sub 1, 3 is our Y sub 1, 4 is our second value of X in the second ordered pair, 5 is our Y sub 2, 5 is our X sub 3 in the third ordered pair, 6 is our Y sub 3, here, in the fourth ordered pair, this will serve as our X sub 4, and this will be our Y sub 4, which is 7. Now, why is it important for us to identify our X and Ys in each of the ordered pairs? Because these values in a domain are the critical values to identify if it's a function or not a function. Why? Look at this. We have 2, 4, 5, and 6 in the domain. No X value is repeated. So 2 is distinct from the rest of the domain, that's 4, 5, and 6. Thus, we consider this as a function. This set is a function. Remember that. When there's no X value that has been repeated in the given set, then that means it's a function. Second example, this set. We have 3, 3, 4, 5, 5, 5, and 5, 4. So again, the first step is, let's identify the X and the Y elements like this. Followed by, yes, we are going to identify the domain. So meaning all the X values in our ordered pairs. We have 3, 4, 5, and 5. Now, notice that here, 5 is repeated. That's the X value. It's repeated. For that element in our X or in our domain, we do have two different outputs, which is not anymore the definition of a function. So this is not a function. Well done. We are done with the second illustration for sets. Again, we're done with mapping and we're done with sets. Now this time, let's focus into another way, and that's for graphing. how do we identify if the given graph is a function or not? Your probe there is being pointed. It's VLT. That will be our magic keyword to identify if the graph is a function or not. How? What do you mean by VLT? VLT stands for Vertical Line Test. Yes, functions can also be determined in graphing. We can use this vertical line test, which is a special kind of test, using imaginary vertical lines, and to check if these vertical lines would touch the graph only once. Otherwise, it is not a function. What do I mean by that? If the vertical line hits 2 or more points on the graph, it is not considered a function. Let's look at some examples. Look at this graph. How would we know if this graph is a function or not? Again, what's our magic keyword? We'll be using VLT. That's the vertical line test. Right. So that's it. The blue line that you see on the screen right now, that's an imaginary line. Yeah, it's not part of the graph. We just made that line to test if the given graph is a function or not. I hope you're following. So, the point there is here, which means that the line, the vertical line, touches the graph at that point only once. Now let's move the blue line. Let's move the blue vertical line. Because here, you can check if it's a function, if any point of the graph, it would only touch the graph or the given graph once. So let's move the vertical line. How about there? Yes, it only hits or it only touches the graph once. How about there? Only once. And finally, right here, yes, it only touches the graph once. Hence, we can say that the given graph is a function. So that's an example of a function, basing on the graph. Let's look at another example. Identify if this graph is a function or not a function. Let's check. Let's create our imaginary vertical line. Again, we will be using vertical line test. Right there. The black dot represents the point wherein the vertical line touches your given graph. It's only once, right? Let's move it a little bit to the right. Like there. It touches the graph how many times? Still once. Let's move it. There. Still once. Last one. Over there. Still it touches the graph once. Based on that, we can conclude that the given graph is indeed a function. So those are the illustrations, again, for the mapping, sets, and graph. How about functions in real life? This is a circle. So an example of a function in real life is the circumference of a circle. The circumference of a circle is a function of its diameter. It can be represented as circumference, or C of D, is equal to d pi. Alternatively, we can also use it as a function of radius, which is C of r is equal to 2 pi r. Another example is a shadow. The length of a person's shadow along the floor is a function of their height. And the third example is driving a car. When driving a car, your location is a function of time. What you need to remember: a relation is a function when every x value is associated to only one y value. Do not forget that. You can illustrate functions through graphing, mapping, or sets. And lastly, functions can be seen in our daily lives, like driving a car, wherein your location is a function of time, the length of your shadow, which is a function of one's height, and a lot more. To be specific, this is for the second lesson, entitled Evaluation of Functions. What you need to know. At the end of the lesson, you are expected to substitute values in a function and evaluate a function. What's in? Now, before we dig deeper about evaluation of functions, let's recall significant points about our first lesson. That's about functions. Now, function can be related to the picture that you see on the screen. What is it? That is right. This is a machine. This is a function machine. Why? A function is like a machine that relates this, which is your input. In this example, that's the strawberry. It relates the input to this. This is the output. In this example, from strawberry, the output is now the ice cream popsicle or the ice pop. That is our function machine. From the input, relating it to our output. Because remember, a function is a special type of relation. Now, what's inside this machine? For us to understand why our input has been changed into our output. Let's get inside. Because inside our function machine, there's a rule. So every time our input gets inside the machine, it follows a rule that leads to our results or our outputs. I repeat, our input gets in, follows the rule, and then gets out as an output. Remember that. Remember our function machine to recall the meaning of functions. So how do we write and read functions? Let's have this. You can write it using this function notation. And you can read it as this. If this is f of x is equal to the given. Again, that is f of x is equal to the given. Okay? So another way of writing that is we can also use g of x, h of x, and other letters. Traditionally, functions are referred to by single letter names like the one shown on the screen. However, you can also use any letter or letters to name a function. So let's have an example. We have here this function. You read it as f of x is equal to 2x plus 1, right? One more time, that's f of x is equal to 2x plus 1. Now you can rewrite that in this form. That is, y is equal to 2x plus 1. Notice, f of x and y. I mentioned that you can rewrite this, right? Meaning, f of x, you can rewrite it as y. F of x notation is another way of representing the y value in the function, which means these two are considered as equivalent notations. So they mean the same thing. Now let's go back. F of x is equal to 2x plus 1. Here, x stands for the input, similar to the input in our function machine, and this time, this would be our output, 2x plus 1. What's new? How to evaluate functions? Let's have this. Let's evaluate this given function. The function is f of x is equal to 3x plus 4 if x is equal to 2. I repeat, you are going to evaluate this function, f of x is equal to 3x plus 4 if the value of your x is equal to 2. Another way of presenting the question if you're asked to evaluate a certain function is like this. Find f of 2 if f of x is equal to 3x plus 4. So if you encounter this question or this statement, it means the same thing with the previous statement. So here, it means the same thing. Why? F of 2 means that the x value would be equal to 2, which is similar to this right here. X is equal to 2. So I repeat, this is another way of presenting this. Alright, so how do we evaluate this function? Let's see the steps. Step 1, copy the given. So the given function is 3x plus 4, so we'll copy that. So we have here, f of x is equal to 3x plus 4. That's step 1. Step 2, replace x with 2. So we have now this one. We substitute the values of x, which is 2, in the given equation. So we now have f of 2, right here, is equal to 3 times 2 plus 4. Next, third step, perform the indicated operations. So that means we will multiply 3 and 2 on the right side of the equation. So we will copy first f of 2 is equal to 3 multiplied to 2, the product is 6. Then copy plus 4. So we have here 6 plus 4. Now, as we move on to the next step, we need to have here still performing the indicated operation, which is now addition. So we will add 6 and 4. The result is, that is right, 10. So the final answer here is f of 2 is equal to 10. So that's how we evaluate this function. Take note if the value of x is 2. What you need to remember. The classical way of writing a function is in this form. F of x is equal to the given. You can also write it in g of x, h of x, or any other letter or letters. Second, keep in mind that to evaluate a function is to replace or substitute its variables with a given number of expressions. And finally, it is recommended putting the substituted values inside the parentheses so you don't make any mistakes. To be specific, this is for lesson 3.1 under operations of functions, specifically for addition of functions. What you need to know. At the end of the session, you are expected to follow the steps in adding functions and add functions. So we have two main goals for this session. What's in? Let's recall the rules on how to add integers properly. Now, I know for a fact that you find this very elementary because you had this in your past years. Now, specifically in your junior high school from grade 7, right? Now, do not worry, we'll just have a run through of the rules for us to concretize our learning on those topics. So let's have now rule number 1. So let's have 2 plus 9. Rule number 1 of addition of integers states that the sum of two positive integers is a positive integer. So for example, we have here 2, which is positive, and we add it to another positive integer, that is 9. So the expected answer here will be positive, since that's rule number 1. Now, allow me to introduce to you another way or a strategy that we can use to remember each of the rules, beginning with rule number 1. So here, when we say positive, let's have a color coding for that, or code for that. Let's use the color red. So here, that's for positive 2, and this one is for positive 9, since they have the same sign, which is positive. Now remember, or notice, that since they have the same color, so that means we can combine the two integers, leading us to a positive 11. So that's it. Remember that if they have the same sign, thus the same color, you can combine and the result will also be the same sign. Okay, let's have another one. Rule number 2. What if the two integers are negative? So here, the rule states that the sum of two negative integers is a negative integer. So here in our example, we have -2 and then the sign there is negative, and we have also -9. Making use of the strategy that we've introduced earlier, this time we will not anymore use the color red because that's for positive. Let's use color blue like this, and for -9 like this. Observe that they have the same color. Or that will be our way of remembering that we can combine the two and we will have a -11 since the color of the result is negative. It will follow the sign since both have the negative sign. Were you able to follow? Okay, rule number 3. What if only one is negative and the other one is positive, meaning they have different signs? So here, rule number 3 states that if the signs are different, subtract the numbers and use the sign of the larger number. Again, if they have different signs like this, you have -2 and the other one is 9, getting the sum of the integers, the process is you're going to subtract the numbers and use the sign of the larger number. So let's use here -2 like this for a blue color and 9 like this, similar to earlier. So you're going to subtract like this, and the result will be a red since that will be for the larger number. In this example, 9 is larger than 2, thus we will follow the sign of +9. So the result is +7. Let's have what's new. How to add functions. In adding functions like f of x and g of x, we will follow this notation. F of x plus g of x, or we can use this, f plus g of x. Again, you read it as f plus g of x. Let's have this. For example, your f of x is equal to 3x plus 2 and your g of x is equal to 4 minus 5x. So how do we add the two functions here? Let's follow some steps. We have here step 1, write the sum, like this. You'll have this notation, f plus g of x. Then we have here equals 3x plus 2 plus 4 minus 5x. Now, how did we come up with that? This one is, observe that will be your f of x, 3x plus 2, enclosed in a parenthesis. And the other one will be your g of x, that's 4 minus 5x, enclosed in parenthesis. So every time we add the two functions, do not forget that we need to enclose it in a parenthesis. Second, arrange. We are going to arrange the terms according to the degree, from highest to lowest degree. So here, notice that -5x and 4 must be interchanged to arrange the polynomial. So it will be like this. -5x plus 4 for g of x. So from here, we are going to introduce two methods on how to get our answer. So let's start with method number 1. This is for the horizontal method. So all of our answers are written horizontally. So this will be it. Okay, let's take out the parenthesis, so it will look like this. But we are going to retain this parenthesis inside our negative expression. After that, we have this. We are going to combine like terms. So we have 3x and -5. So they're written beside each other. And the other one is for both constants, 2 and 4. Now going back right here, we are going to apply the rules of adding integers for the numerical coefficients. +3 and -5. So we are going to add that. And we are also going to do the same thing for the constants 2 and 4. So let's reveal the answer. So the answer is -2x plus 6. Why? Because this one, how did we get -2x? That's from 3x plus -5x. 3 plus -5, following rule number 3, will give us a -2. Okay, and we copy the variable x, so the result is -2x. We get 6 from the sum of 2 and 4, following rule number 1. Okay, so that's -2x plus 6. Let's have the second method. This time it's for the vertical method. So for the vertical method, what we have here is for f of x, 3x plus 2, and we also have g of x, -5x plus 4, already arranged according to the decreasing order of its degree. We are going to align expressions having the same degree. So in this example, we have 3x and -5x, so we are going to use the rules of adding integers, so the result will be -2x, right? Then the next one is we have 2 and 4, that will give us a +6. So the answer is -2x plus 6, similar to our horizontal method. Observe that we also have here the factors. When you write -2x as the first expression, it could be written as -2 times x, right? And 6 can also be written as -2 times -3. Now, what do I mean by that? Because another way of writing our answer here is using our common monomial factor, which you've learned in your junior high school grade 8 level. There. So our common monomial factor is -2, right there. Remaining inside the parenthesis would be the first expression x, followed by the -3, so that will be our binomial. So aside from -2x plus 6, we can write it in this way. -2 multiplied to x minus 3. Next one, what you need to remember. Remember that the sum of the functions can be written as this, f of x plus g of x, or can write it in this notation, f plus g of x. Second, you can add functions horizontally or vertically after arranging the terms according to their degrees. Last one, these are the steps in adding your functions. Write the functions into this, f plus g of x is equal to f of x plus g of x. Reorder the functions by degree of terms. And lastly, add functions horizontally or vertically. We are now in lesson 3.2 under the topic operations of functions. To be specific, that is subtraction of functions. What you need to know. We have two main objectives for this session. So at the end of the session, you are expected to follow the steps in subtracting functions and subtract functions. What's in? Let's recall how to properly subtract integers by recalling its rules. Now, similar to the addition of integers, we have set of rules, but this time for this video presentation, we are going to make use of a strategy for us to easily recall and manipulate integers. Now, let's try to have a look. For example, we have 5 minus 17. To do that, we will be making use of this. Keep, change, change. Now, in our description box below, I am going to post there the reference link for this strategy. Keep, change, change. Now, what do I mean by this? We are going to keep the first integer, keeping its sign. So we are going to keep it as positive 5. Second, we will change. This time, from subtraction, we will change that to addition. And the last one there is 17. We will change that to negative 17 from positive 17. Were you able to follow? I repeat. We keep positive 5. We change the sign from negative to positive. And we change the given from positive 17 to negative 17. So that's it. Keep, change, change. Keep that in mind. So how do we solve 5 plus negative 17? We will be using the rules in adding integers. We are going to add, the result is negative 12. How do we subtract functions? Given functions f of x and g of x, we will be using these notations. F of x minus g of x, which means the function f of x is being subtracted to the function g of x. Another way of writing that is this notation. F minus g of x. I repeat, that is f minus g of x. Given f of x is equal to 3x plus 2 and your g of x is equal to 4 minus 5x, let's find the difference. Let's find f of x minus g of x, or f minus g of x. To do that, let's follow these steps. 1. Let's find the difference by writing it in this form. F minus g of x is equal to 3x plus 2 minus 4 minus 5x. Where did we get these expressions? This is your f of x, and this one is your g of x. Second step, we are going to arrange. Observe that here the binomial is not yet arranged in decreasing order of its degree. So we are going to arrange that. It will look like this. From there, we are going to use keep, change, change. So we will keep this, the first given expression, the f of x, 3x plus 2. We will copy that. Next is we will change the sign from negative, that is from minus, to plus. And here, the next or the last binomial, which is your g of x, will now be, yes, we will change the signs. So from negative 5x to positive 5x, and from positive 4 will be negative 4. Why are we doing that? Since we have keep, change, change, we are also changing the signs of all the terms in our polynomial. Here, to be specific, that is your binomial. I hope you understand. Let's move on. After that, we will do this. We will take out the parentheses. It will look like this. And we are going to combine like terms, so we are going to have 3x plus 5x, and we are also going to combine the constants 2 and negative 4. So here, we will be making use of the addition of integers by adding the numerical coefficients of x. So we have 3 plus 5, that will give us an 8x. And here, 2 minus 4 will give us a negative 2. So the answer will be 8x minus 2. That's for method 1. Now we are making use of the same methods in our addition of functions. So we have 2 methods, so this is for method 1. Let's try to have a look for our method 2, that is the vertical method. This will be your f of x. So we will be making use of keep, change, change. We will follow that. We will keep that. We will change this to positive, so we'll have plus from minus. Then we will change the signs of the expressions. So from negative 5x plus 4, it will now be 5x minus 4. Making sure that it's arranged or it's aligned to the same variable having the same degree. So here we have 3x and 5x, and we also have 2 and negative 4 on the next column. So let's add 3x plus 5x will give us an 8x. Good. And here, the next line, we have the constants. 2 plus negative 4 will give us a negative 2. So the answer is similar, is exactly the same with our method 1, 8x minus 2. But here, notice that they share a common monomial factor. So if you're going to rewrite this into its factors, we'll have this. 2 multiplied to 4x. Those are the factors of your 8x, right? We'll copy minus, and we can write the factors of 2 as 2 and 1. Okay, so here we observe that they share a common monomial factor, that's 2. So we'll take that out. And here, remaining inside the parenthesis will now be 4x and 1. So we have 4x minus 1. So another way of expressing our answer, 8x minus 2, will be 2 multiplied to the quantity of 4x minus 1. Last one, what you need to remember. Keep in mind, senior high school students, that you can write the difference of functions in these notations. We have f of x minus g of x, or we can also use f minus g of x. Another note is you can subtract functions horizontally or vertically after arranging the terms according to their degrees. And last one is, the steps in subtracting functions are as follows. Write the functions into this form, f minus g of x is equal to f of x minus g of x. And reorder the functions by degree of terms and add functions horizontally or vertically.